Welcome guys. In this video we talk about the NK cells, natural killer cells, and we talk about the COVID-19. Okay, we talk about what is the role of natural killer cells towards the COVID-19, and we also talk about the natural killer cells is present in children in a large amount, but in adults the natural killer cells are in lower amount present in the adults. Okay, so we talk about also on that topic, and we also talk about the natural killer cells towards the role of the natural killer cells towards the COVID-19 or towards the infection. Okay, so stay with me and know about this topic. First of all, I would like to say here the NK cells, it's related to the innate immunity. It's a part of the innate immunity. I can say here it is this cell, this cell belongs to the innate immunity. Okay, I hope you heard the name of the innate immunity. Innate immunity is that immunity when a pathogen makes an entry. Okay, when a pathogen or when a foreign particle makes an entry inside the body, so the innate immunity responds at the beginning of the pathogen, at the beginning of the entry. Okay, so in innate immunity there are some cells like neutrophils, there are present macrophages, there are NK cells, as the topic is based on today's topic is based on the NK cells. So the NK cells, it is the first responder. Okay, we can say it is the first responder, the NK cells or the innate immunity. Okay, at the beginning when the pathogen comes inside our body, the NK cells or the macrophages or the innate immunity responds at the beginning of the entry when the pathogen comes inside the body. Okay, so in this video we talk about briefly about the NK cells. Now we talk about what is the role of the NK cells and why the NK cells are present in children in a large amount, and why the NK cells present in adults in a lower amount. Okay, so first of all we talk about the role. Okay, role of the NK cells. So I draw here. Let's come here for a second. Suppose this is a cell. Okay, this is a cell, and this is a NK cell, natural killer cell. Okay, and this is a healthy cell. The NK cells are like a cop, okay, or like an inspector. It checks everything inside the body. For example, the cell inside the body, the cell, this NK cell goes and checks the cell is whether it is perfect or not. Okay, so this is the NK cell. It's a healthy cell. Okay, and here it's an unhealthy or it's a infected cell. Okay, so here are also the NK cell, natural killer cell. What happens, there are two cases. In first case there are present healthy cell, in next case there are present infected cell or there are present unhealthy cell. We see what is the role of NK cell towards the healthy cell and what is the role of NK cell towards the unhealthy cell or towards the infected cell. Okay, the NK cell, this NK cell checks this cell. Okay, this checks, this is the nucleated cell. There are present MHC molecule, MHC class first, MHC first, major histocompatibility first class first. Okay, all nucleated cells contain MHC class first. MHC class, the job of this MHC class, it presents the antigen, or it presents the piece of antigen, or it presents the piece of the pathogen. Okay, so it's the job of the MHC first. In nucleated cells, the NK cell comes and checks this cell. The healthy cell represents the MHC molecule, okay, on the surface, and this NK cell makes the bond like to the MHC molecule and checks. There are also some other receptors which checks the cell is perfect or not. Okay, so the NK cell comes and makes the bond like. Okay, it checks whether the cell is perfect or not. It is the job of the NK cell. If there are any problem inside the cell, we will show in the next case there are infected cell, but in this case, in healthy cell, in this case, in the first case, there are the healthy cell, and the NK cell comes and checks this cell whether the machinery inside the machinery is okay or not. Okay, so the NK cell comes and makes to the bond to this healthy cell. If the connection is good, if this connection is good, this is the MSC molecule. If there are this is the receptor, okay. If this connection is good, everything is good, so this NK cell goes away because the cell is good. The cell's machinery is very perfect. Okay. What happens? The NK cell comes, okay, makes the bond with the healthy cell and makes sure the cell is perfect or not. Okay, as I said, it is like an inspector. The inspector comes and shows and sees is everything perfect or not. It's the inspector of the body. We can say this cell is the inspector inside us. Okay, it checks is everything is right or not. So the NK cell comes and makes the bond to the healthy cell, and the healthy cell, it's perfect, it's working good, so the NK cell goes away. Okay, now come to the next case. In this case, there are present unhealthy cell. Okay, there are present infected cell. Actually, this cell is infected by, let's say, COVID-19. Okay, inside the cell there are virus. Let's say this is a COVID-19. What happens in this case? The NK cell comes. Same thing happens here. But in this case, the cell is infected by virus or by pathogen. Okay, so the cell goes and finds the MSC1 here, but the MSC is damaged. MSC1 is damaged because the cell is damaged here. So the NK cell makes the bond, makes the bond with this cell, but the cell is not good, but the cell is infected. Okay, so the NK cell, when it's not find the MSC1, and there are also other receptors, phospholigands, and they also check the cell, is cell perfect or not. Okay, so the NK cell, when it's not find the MSC1, okay, when it sees the cell is infected, maybe pathogen, maybe virus. Okay, what's the role now in this case? The NK cell's role towards this unhealthy cell, the NK cell releases some chemicals, okay, towards this infected cell. What happens is it releases perforins. Okay, perforins go and makes the holes on the surface of the cell, or makes the pores, okay, surface of this cell. Suppose this is the holes here. Okay, so it sends the perforins, and the perforin's job is makes here the holes or makes the pores. Now when the perforin's makes here holes or makes the pores, it releases the other chemical that's called, it releases, actually it throws the garnets. Okay, it throws the garnets to this cell. What it releases? Grain enzymes. Okay, grain enzymes, and releases this NK cell releases grain enzymes to this cell, or we can say here, it throws the garnets. Okay, and garnets goes inside these pores, and for example, this is the enzyme. Now this enzyme's work is, it tells the cell, now get ready for the apoptosis. Okay, apoptosis means the cell death. Okay, now apoptosis happens in this cell. It suicides. We can say it suicides. Now the cell suicide, because the cell is infected if the NK cell not checks this cell. So inside this cell there are present the virus replicates. Okay, it makes 100 copies, it makes millions copies inside the cell. Okay, but the NK cell checks this cell, and this cell is infected, and it releases some chemicals and damages this cell. Okay, it's the job of the NK cell. That is why we call it natural killer cell. Okay, come and next here I also draw this. So here this is the healthy cell. This is the as I draw here. This is the NK cell, and this checks. This is the natural killer cell. This checks the healthy cell. Okay, this checks is so here is everything perfect, and the cell goes away. There also makes the bonds. Okay, inside here and here. So the NK cell checks here, the cell is perfect, so the NK cell goes away. In the next case, the cell is infected, okay, by virus. The NK cell checks, but it's not finding here the MSC1. Okay, in this case it's not finding. It's actually the cell is infected by virus, so it's not finding that the cell is giving this cell is not giving the good reply to the NK cells, or good response to the NK cells. So now the NK cell releases, as I said here, the NK cell releases some chemicals, and the first chemical, the chemicals makes their pores on the surface. So after that it throws the bombs, or it throws the grenades to the cell and damage to the cell. But there are another job of also this NK cells. It releases some other chemicals like interferon gamma. Interferon gamma sends, like it, these are the cytokines actually. These are the cytokines. These are the messengers. Okay, so in this case it sends the signal to the other cells, or it activates to the phagocytic cells. Phagocytic cells like macrophages or dendritic cells. These cells are phagocytic cells. Phagocytic means they engulf the dead cell, or they engulf the pathogen, whatever there is. So the job of these cells is the engulfing. Okay, they eat the dead cells or the pathogen, whatever there is. So the job of the macrophage or dendritic cells, these cells are present in the innate immunity. Okay, first as I discussed the innate immunity. So the NK cell sends the message to the phagocytic cells, come here, and it releases interferon gamma. Okay, here it also releases some other messengers to send to the other cells. Okay, it also releases some messengers for the other NK cells, come here, and because I'm destroying this cell. Okay, and because the cell is infected by pathogen, maybe pathogen or maybe a virus. So this is the job of the NK cell. Okay, now come to the next thing. If there are these NK cells, if there are reduced number of NK cells, for example, let's assume that here is the person catched the COVID-19 virus. Okay, catched the virus or catched the disease, but the person's NK cells number is very low present inside the body. Okay, I hope you saw the children's, if they get the disease, they recover very fast, because the NK cells are present in children's in a higher amount rather than the adults. Adults have low lymphocytes, that's why they recover very slowly, but the children recover very fast. Okay, I will talk about later. So here, if the NK cells are reduced in a COVID-19 patient, what happens? So there are another immunity also. There are the present adaptive immunity. They make the antibodies towards the pathogen, or towards the foreign particle, or towards the virus. So first of all, we need the innate immunity. Okay, every person need the innate immunity, because at the beginning they attack the pathogen or they attack the virus, but the adaptive immunity takes some time. The adaptive immunity takes 8 to 10 days. Okay, 8 to 10 days, but this immunity, the innate immunity, gives very at the beginning respond to the pathogen or to the virus. So if the NK cells are reduced in number, or if the NK cells are exhausted. Okay, I will talk about briefly about the exhausted, how the NK cells are exhausted, or they look like lazy. First of all, I remove it. Suppose this is the NK cell, but the cell is lazy. Okay, it's not working very properly. The NK cell is not working properly. Okay, in this case, for example, there is the cell, but the cell is infected. The cell is infected. Okay, but here in this case, the NK cell is lazy. It's exhausted. Okay, in this case, it cannot judge whether the cell is infected or not, because this cell, it's not working properly itself. So how can it judge the other cell is correct or not? In this case, the NK cell is not working very properly. It cannot judge, is the cell is infected or not, is the cell is healthy or not. So in this case, the NK cell itself, it's not working properly. Okay, it's lazy. Now in this case, the virus replicated fearless, because the NK cell is not working properly. And if the NK cell is not working properly, it cannot release the messages, release the other chemicals, like here interferon gamma. It activates the macrophage cells. Because it's not perfect, it's not working properly, so it cannot release these things, or it cannot release the other messenger chemicals to message the other cells. Here are the cell, it is the infected. Okay, so this cell is infected. For example, I repeat, this cell is infected, but this NK cell cannot judge the cell is infected or not. So this cell can also, this NK cell cannot release other messengers or other chemicals to inform the other cells. Here is the cell, but it is the infected. And it also cannot release, as perforins, which can makes here pores. So the virus inside the cell, the virus replicating very, it replicates very rapidly, or it replicates fearlessly. Okay, it has now, this virus, it has no fear of NK cell, because the NK cell is not working properly. Okay, it's the another case. Now come to the next thing. As I said, the children have higher amount of the lymphocytes, but the adults cannot. The children and the adults, okay? The children have higher amount of the lymphocytes, means they have the higher amount of the neutrophils, they have the higher amount of the NK cells, okay? Higher amount of the NK cells. But in children, when the children get the disease, any type of disease, they recover very fast, very rapidly, because the higher amount of the NK cells. The NK cells, it is the beginning response of the pathogen or virus or disease. So the NK cells, these NK cells are present in higher amount of the children, but in adults there are lower amounts of NK cells. Why there are in adults? Why there are present lower amount of lymphocytes or NK cells or other cells, immune cells? Because in children they are actually growing. Okay, the structure of the children, they are actually growing. That's why there are present the higher amount of the lymphocytes. Okay, or higher amounts of the NK cells. In adults there are lower number of the NK cells. Okay, lower number of the NK cells. Okay, in this the NK cells are higher number, and in adults there are lower number. So adults recover slowly. That if the adults gets the disease, the adults recover but very slowly, rather than the children recover very fastly. Okay, because of there are the large amount of the cells. If, for example, if the virus comes inside the children, okay, comes inside the body, so there are present also higher amount of the immune cells. There are present higher amount of the phagocytic cells, NK cells, natural killer cells, so they can fight. Okay, and if there are coming large amount, but there are also present a large amount of natural killer cells or other cells. But in this case, the adults, if the means in the children, the innate immunity can fight, okay, towards the pathogen, towards the whatever the coming is, whatever, for example, any foreign particles. So in this case, in adults, if the foreign particles coming in a very huge amount, in a very large amount, but there are present lower amount of the cells, so they cannot fight. The innate immunity cannot fight very. The innate immunity means the innate immunity cannot respond very properly to the large amount of the pathogens or large amount of the virus. Rather than this, children can, because there are present in children, there are present a large amount of the cells, there are present large amount of the immune NK cells, so they can fight. That's why the children recover very fast rather than the adults. If the NK cells are present a large amount in children, that is why the children shows some small amount or some mild symptoms of any disease or COVID-19. Okay, so now in next thing, if the NK cells, if the natural killer cells are exhausted means, suppose here are the NK cells, this is the NK cell, okay, but the NK cell, it is this natural killer cell, it is exhausted, it's a lazy, like I can say, we can say it's a lazy, it's not giving that response very perfectly, but as I said, the job of the NK cell to check the every cell, but this NK cell not checks very perfectly to the cell. For example, here are the unhealthy cell, okay, it's the infected cell by COVID-19, okay, this cell is infected, this cell is exhausted, it's not, it shows the versatility very lazy type, this cell is very lazy, okay. So when this cell checks this cell, it cannot judge very perfectly the cell is infected or not. That's why I call the lazy type. Okay, this cell is exhausted. In exhausted cells, the NK cell is not shows the perfect job towards the cell, or if there are, as I said here, if this is the infected cell, okay, this is the infected cell, but the NK cell is not very sure about this, is this infected or not. in NK cell, if this is the lazy or this is the exhausted, okay, near the NK cells, near the another here are the another NK cells, it releases some chemicals here and makes other cells lazy. Okay, there are the another cells, there are the another NK cells near to this cell. It makes these cells like itself. For example, this, as I said, this is the lazy cell. Okay, this cell makes these two cells, or there are two cells near this cell, there are other two cells. This cells also makes these cells like lazy by some receptors, by some chemicals. If there are, but it's in COVID-19 case, it's in SARS, the studies comes in SARS-CoV-1. In SARS-CoV-1, the studies shows that there are the virus exhausts the NK cells, and the exhausted cells, the NK cells, makes the other cells also lazy. So the studies comes in SARS-CoV-1, but I do not know in COVID-19, in SARS-CoV-2. Okay, I hope you like this video, enjoy this video, comment this video. Thank you.